All right, let's begin. Thank you very much for attending. I am super excited to be here, to be doing a talk in person. I'm sure everyone is saying that at the start of their talks, that they're excited to be seeing real faces in front of them again. And a big advantage of in person is something I've put up on my screen there. If you have any questions after this talk, please do just come and find me the rest of the conference. I'll be here throughout the rest of the day, through the evening social, here tomorrow. By coming to this talk, you've earned yourself a license to bother me and ask me any questions you might have. And if you don't want to come up and talk to me in person, for whatever reason that might be, you can also tweet me at M1KE. Just send me a message and I'll get back to you. The reason I'm talking about this topic is because it's a topic that excites me, that I really enjoy, and helping other people to understand sort of the serverless world and what it means for them is something I'm passionate about. And so I would, I'd love people to talk to me and engage with me on that if it's something that you think will help in your personal projects, in your business, or whatever else you're working on. I should also mention, I work for a company called Students.com. I'm CTO there. We have a development team, and we are hiring developers. So if you're interested in the stuff we're doing here today, a lot of the stuff here has been learned during the course of my day job. If you want to work in a team that values a lot of modern programming concepts, that does things like come to conferences, that is utilizing serverless technologies, serverless databases, please do come and talk to me about working with us at Students.com. So before I begin properly, this is a tutorial session. These are, previous conferences, there's been a few of these, and they've been a bit more structured. I'm the only tutorial this conference, so I guess I have a sort of unique position to explain that to you. They're not workshops. I'm not going to be able to sort of walk around and give everyone individual attention as much as I'd love to, because there'll be too many of you to sort of debug everyone's laptop problems. But they are a bit more interactive. I'll be running most of this as like a live coding session, so you'll be seeing me do things. But you can follow along, and I do encourage following along. I think you'll probably gain more from it. So you can check out, there's a Git repo there at the top, bit.ly/PHP UK-serverless. Find that repo, check it out, or clone it locally. And there are also steps. So you see that at the moment I'm in the branch step 1, and my laptop's going to sleep. And there is a step 1, step 2, and step 3. So if you're struggling to follow along for whatever reason, and we switch from step 1 to step 2, you can just do git checkout step 2, and you'll be up to speed with where I am. So it's sort of here's one I made earlier thing. The only time we don't do that is there isn't a final step that gets you to the end of step 3. So step 3 is the one where you really want to pay attention, which is good because it's at the end of the 2-hour block. The session is like 2 blocks and then a break. I am probably just going to power on through the break, but because it is sort of interactive, if you need to step out for a moment and come back, it should be relatively easy. We might have like a 5-minute split depending on how I'm doing for time, but this was originally meant to be a 3-hour workshop, and I've had to condense it already. So I don't want to talk too fast. I want you to all understand what I'm talking about, so we might just try and use the whole time. I will try and open a bit for the end at questions, but as I say, the real Q&A time should be afterwards in the social, because then we can actually have a far better conversation than me shouting at a room full of you. If you want to follow locally, Docker and Docker Compose are going to help you on your local environment. And if you want to be deploying to AWS, you'll need an AWS account with relatively wide permissions to create resources. And you will need at least Node 12 on your machine to install the serverless framework. Again, previous years with these tutorials, they have emailed out these requirements beforehand. That didn't happen this year. So if you are feeling, oh, I wish I had installed this stuff, I didn't know, I'm sorry about that. But you could maybe install it now. The Wi-Fi here is relatively good. So let's begin. Before we talk about the actual application we've built here, I want to talk about why serverless. Serverless is a great buzzword because we all tend to hate servers. So the idea of not having them is a really good thing. Obviously, we also know that there are still servers involved. If I am hosting something on the web, I need a server. If you're doing anything with any sort of internet-connected system, you need servers, you need clients. We cannot get away from that factor. So serverless, buzzword, doesn't necessarily mean what it says. Just like the whole thing in the cloud is just someone else's computer. So what does serverless mean? It doesn't mean that there are no servers. It means we have to care about servers less. We have to no longer think about how many cores our machine has, how much RAM our machine has, whether its swap space is full, whether its hard drive is full. Has it been patched? Have not just my underlying operating system been patched, but have my tools been patched? Has Apache been patched, or Nginx been patched, or PHP been patched? All these different things we use. Have I got root access configured? Have I got SSH configured? Can someone sign in without a password? Can someone sign in with a weak key? All these different things that are going to expose us to issues where our application goes down because the server runs out of swap space. Issues when we get hacked because we had open root access. And every issue beyond that, when we get to the application level and we find some CVE comes out for something called log4shell straight before Christmas. All these things can be mitigated very much by a serverless environment because the challenge of building that software, of building that hardware, the configuration, is taken away from you and given to, generally, a cloud provider. In this talk, we're going to be primarily talking about AWS. That's where I have my experience, and I feel you should talk about what you're experienced in. However, a lot of the principles of serverless will apply across cloud providers, so across the big three, AWS, Azure, and GCP. But also across smaller cloud providers or people hosting custom solutions on things like Kubernetes and a variety of other providers. For example, even Cloudflare now offer serverless in their compute at the edge. So it's the serverless environment and the idea of people just wanting to say, I've got some code, I want to run it somewhere, is just really taking hold. Developers want to get stuff into production faster. They also want to get stuff into testing faster, into staging faster, and serverless allows those things as well. One advantage of serverless is our entire environment tends to come as a single file. We'll see that in a moment. And that means that if I want to spin up a test version for this new branch I've been working on, I can do so. I can get a URL for it in minutes and send it to someone else on my team to test or to demonstrate. So serverless is not just improving our production resiliency, but it's going to improve our development speed. And it's going to improve the control our developers have over the overall workflow. If our developers have to get to a certain point where they stop and they hand over to the ops team because this new system requires a PHP extension we didn't have previously, that's going to stall development. That's going to, that goes into a queue. That takes a while to get done because of other priorities, especially in multi-team setups. Again, serverless is really great because it allows that abstraction. Serverless works very well with microservices, but I will say serverless doesn't have to be used with microservices. You can run a monolith serverlessly, and we're actually going to see some examples of how we can do that in today's presentation. But serverless does work in an area where we are thinking about how each resource in our system interacts. So even if we're not microservices in terms of our code being like separate repositories or separate code bases, we will be thinking about how different bits of code interact with different parts of our database, how they interact with queue services, how they interact with API gateways and authentication. And in this case, we're going to use a real project. So I decided that if we're going to demonstrate serverless, a sort of hello world just isn't really good enough. It doesn't show us the need for why we want to be serverless. And so the project we're using today is actually a project I made for a real-world use case, which is a simple payment system using Stripe. Many people, actually, to show of hands, who's used Stripe or Stripe's APIs before? There we go. Good. I knew I picked the right one. So Stripe, great payments API. One challenge of Stripe is that there isn't just a simple plug-and-play service for someone who's non-technical. If you want to host Stripe payments on something like a WordPress website, there are plugins you can buy to do so. You generally have to also be on a higher level of membership for WordPress.com. And that's the same with many things like Wix, Squarespace, website builders. And even hosting your own Stripe integration starts requiring quite a lot of complex work. Custom coding, handling things like webhooks, which tell you whether a payment succeeded or been charged back, days or weeks or months after the payment date. Building for Stripe is not necessarily simple. And I came across a use case where someone wanted a website to take payments very simply and very quickly. And I was like, it's going to take me a long time to build that. I've got to build it. I've got to set up a server for it. I've got to set up a database for it. That's a lot of work for just taking payments one time. But this person was, in the end, ran their system. They were running an event on Eventbrite, who took 25% of their ticket fees in payments costs. And I was like, that's ridiculous. So this event is happening again this year, and so I built a tool, a platform for them to take their payments for it. And that's the platform we're going to be using today in a slightly cut-down version. The idea here was it doesn't need someone who with no technical experience, but someone can literally go on AWS, run a few commands locally, and they have a payments page. Done. So, any agency, any web company, any individual who knows a bit of computer can deploy Stripe payments for anyone by just creating a Stripe account, dumping some keys in a file, and following a README. So it's the nearest I've got to the perfect system for that. If anyone from Stripe happens to be watching this, let's talk about how we can improve that process further. Before we do this, we want to test our application locally. because we want to actually see what we've built. We have built a payment application, so let's see how it runs. We can run it locally with the following things: Docker, and Docker Compose, and node greater than equal to 12. So I'm on node 14. This should work on node 16 or whatever version node gets to. I lose track of node versions. I think they just sometimes roll the dice. And before we begin, you will have a file, if you've cloned the repository, called env.sample. We're going to be using env files for our different environments as part of this. As a standard process, you want to keep things like, especially keys, in an env file that is not committed to your repository, and sort of make sure that those are secure. Although a lot of people, things like the env development local, you could probably commit that, because I imagine developers would want access to that. So in my case, we've got env.sample, and copying that to env development local, you'll see it's exactly the same, because we have nothing special locally to do this with. When we get to the actual deployment environments, we're going to have a few more differences that you'll want to type out in your env files, because otherwise everyone will start clashing bucket names on S3, because S3 bucket names are globally unique. So if you all use the same default placeholder, whoever gets there first will get the bucket, and everyone else's build will fail. So let's not do that. So we've got our env file as .env.development.local. I'm sorry if the sidebar is a little bit small for people. I can't resize that bit as far as I know. This bit and these bits are easy to resize. I should probably learn more about zooming my environment, but there we go. So we can run a few commands. Docker Compose, run Composer install. I put Composer in the Docker Compose file just because then we're all on the same version, because I imagine that there's, I don't know, like 30 people in here, and you probably have 30 different versions of Composer installed. So we can run Composer install. And this will download your vendor directory. In my case, I've already done that because it's a good idea to test this before you run something. Similarly, we can run npm-i, which is going to download everything we need to run our front end. I built a front end in React for this, just using create React app. So nothing fancy in that sense, but just enough to show you what we're working with. It uses Tailwind CSS as well, so a relatively modern stack in terms of the front end. So there we go. Standard node, 146 packages, and 106 of them have vulnerabilities in them. But luckily, we're running all these in the front end, so we should be fine. And then Docker Compose up -d. If you don't know what -d does, it just means that it runs in the background, doesn't flood your terminal with logs. And the web container is the container that we are running in. And finally, we're going to run npm run start, which should start my React app and open it in the browser for me. React will take a moment to compile that. And then in a moment, I'll have my interface. Here we go, my beautiful full-featured payments page. We can have a look at network activity to see how our front pages interact with the API. You'll see these little random calls to Stripe as we go. Stripe is quite good at sort of bot and fraud detection, so that's just Stripe sending information about the page activity. It's nothing to do with what we're doing. It's just Stripe being a busybody in the browser. So let's make a payment for the princely sum of £5, and with the fascinating description of test, and we can hit start payment. And we get to a page where we complete a payment, and we can look back in here and see we made some requests. So we made a request to localhost. We first made an options request because of cause, because I'm running on localhost 3000, and my API is running on localhost 8080, so we had to do a cause request. Cross-origin resource sharing, if anyone isn't familiar with that one. And then we made a request to our API to set up our payment. And we can see the request. We sent the number 5 and the description test. And we received a response, which has a status code of 200 and client secret. This is part of Stripe's API. The way Stripe handles payments is you create a payment intent in their system. They return you a secret for that client in the browser to complete the payment. So you'll actually see that beyond this point, my platform doesn't make any more requests to the API. It just talks to Stripe. So we can call ourselves test. And put in a test card number. Sorry, that's zip code there rather than postcode. I didn't have time to change that into postcode to be more sensible. But zip codes are quite easy to fake, at least. We hit pay now, and that payment should go through on Stripe. And there we go. We've made a payment. Not particularly interesting at this point, but at least it shows the application works. this application was built in the Slim framework. I chose Slim because it's a great framework for tinkering with things in, and because it's very small, hence the name, it is, I think, ideally suited to something like a serverless environment because it kind of encourages you to build small things, or to build things, in a sort of simple format that doesn't use, a huge number of dependencies for every single thing it does. And Slim has this ability, like a lot of frameworks do, that using Composer as well as downloading the framework, you can generate like a skeleton project. So I built this whole thing from the Slim skeleton project. It's a decent little skeleton project. It adds some user routes, and I just replaced all those with my payment system. Now, an interesting factor when considering Slim, or indeed any other framework, and a lot of these principles I'm about to talk to you about will apply equally to Laravel and Symfony, and other frameworks you might care to use, is that they will tend to need some tweaks to run in a serverless environment, but they don't need that many. And this is a bit different to anyone who sort of looked at serverless sort of pre-2019, where running PHP in a serverless environment required you to basically change the entire way your application worked. The way that a traditional serverless application will work is you will declare your routes in your serverless file, your serverless YAML file, in this case, we're not doing that. We're simply declaring a single route which goes to index.php, index.php, the PHP developer's favorite file name. And in many cases of serverless examples, you'll have, each thing your application does will be its own function. So each route, each endpoint your users hit will be its own function, will do its own thing, which again is kind of the microservice format of things. But PHP applications generally haven't been built like that. You pick any framework up, you will generally have an index.php file, which all requests come to via something like a htaccess or whatever the mapping is in NGX. And then that index.php file works out what it needs to do based on your request. So it'll have a router, it will analyze your path, and it will find out some function to invoke or a class to create or something else to do based on your setup. But ultimately, every single request comes into this one index.php file. Now, that traditionally was not the way that serverless environments worked. And then we have to talk about Bref. Bref is the PHP runtime that we're using here. Bref was created as a way to standardize a PHP runtime in Lambda. For whatever reason, Amazon do not support PHP natively inside Lambda. But in 2018, they added a feature called layers. This allows you to run your own Docker container as the basis of a Lambda function, which makes Lambda suddenly very, very powerful. What early people implementing PHP in that found was that it was very hard to know exactly how you were meant to build PHP to work well in Lambda. Certain extensions would behave differently. The base image is Amazon Linux, which isn't generally an image that we're all running on our own machines, so you had to generally compile your container on a separate machine running Amazon Linux to make sure you got it compiled in the right way to then run on the Lambda layers, which is already extra work. And you got to the point where, to be honest, you are not taking advantage of serverless. I'd said at the start that serverless means you don't have to think about patching, upgrading, all these extra options that you might have. And what was happening was people were spending all their time patching and upgrading and worrying about version configurations. So what Bref has come along and done is two things. Firstly, they've standardized a set of PHP applications. They've got a sort of standard container, and then they have like a more complex container that bundles in just every extension they could think of. So you kind of get a choice of one or the other. I've so far have only needed the standard container. And they have built a build pipeline that whenever a change is committed to Bref, rebuilds the Bref image and deploys it to every single AWS region. So another challenge of serverless, or another advantage of serverless, was meant to be you can go global. You can be running in different data centers, different parts of the world. When you were running your own Docker images, you had to send those Docker images to each location as well, which is just more complexity in your build pipeline. Bref has solved that for us by building their own pipeline, which deploys the images for you. So that's why in this layers section, we have a variable here. The variable here looks at Bref, which is a plugin to serverless, and then runs a bit of PHP inside the Bref repository to find out which region you're running in, and therefore which version of Bref you need, and finds the ID of the container for that version. That means that when you run Bref, it will simply load the right container. Bref publish 2 PHP containers per version. They publish a standard container with just the version name, so they're PHP 7.4, and they also publish an FPM container. What the FPM container does is it handles the mapping of the underlying standard in request from Lambda into your code, and converts it into all the lovely things we're used to with PHP. So superglobals, underscore post, underscore get, underscore server. And that means that any application written to run in PHP running via Apache, so via Apache on mod Apache, via PHP FPM, should work natively in Bref. And that's cool, because now you don't have to think about rebuilding your entire application stack in order to go serverless. You can deploy your application serverless today, with a few caveats. And we're going to go through those now. So the default Slim framework expects you running PHP in a very conventional environment. And so we've had to make a few changes in order to allow us to run on Bref. Let's zoom the right way. Although if people are struggling to see at the back, you feel free to come a bit further forwards. There's a lot of free seats. The first thing we have to do is change the directory. By default, a lot of applications, I know that Laravel does this, and Slim does this, I'm not so certain about Symfony, will have a public folder where the index.php file goes. The idea of this is that you point your Apache or Nginx configuration to the public folder, but then your application looks in the directory above it, and then generally down again for all the rest of your code, which means that people randomly sending path names to your web server can't just browse your code casually. And that's a very good way of doing things. Bref expects there to be an index.php file in the root of your directory. So if you're running Bref, you have to have an index.php file in the root of your directory. So in this case, we had to change the default Slim framework to move that file, and therefore we had to change some of the other directory mappings to make sure they were pointing in the right place. Relatively minor bit of work, but something that could trip you up if you just deploy a Laravel app straight to Bref and are like, why is it not working? Check where your index.php file is. Another thing we have to do is this. So for start, ignore the if false. That's just because of demonstrating without container compilation. When you're running in Lambda, you don't have a writable file system. And this is something that a lot of PHP applications are very used to having. Not only a writable file system in something like temp, but a writable file system wherever they want. So a lot of PHP applications will write local things like caches. So you might have caches for doctrine, caches for reflection, caches for twig, caches for your routing, your dependency injection, various caches that tend to be written to your file system to speed up the work of PHP. If you want to save caches to Lambda, the only place you can save them to is /temp. But also be aware that the way Lambda works is a request comes in, it creates a container to handle your request, and then that container hangs around for a little while. There's not a defined amount of time it hangs around for, but it's a short amount of time. And then that container disappears again, at which point anything in /temp is lost. If your application relies on a sort of pre-compilation step where the first few users to request something causes all these doctrine caches to get built, all these twig caches, all these dependency injection caches to get built, but then every other request is quick because those caches now exist, that is going to be a problem for you on Bref. Because this temp directory, if you have say you had a weird system where for some reason someone was sending you a request every 10 seconds, at that point, your application might just use one container for a very, very long period of time. Because it would get a request, it would handle it, it would wait, and it would get another one, handle it, wait. At that point, you might actually find that your caching mechanism works. That doesn't tend to be the traffic of most of our applications. I would love to know what you're doing if you can guarantee a set number of requests every few seconds, exactly. It would be fascinating to know what you're doing with that. But most of our applications, the traffic looks like this. It's spiking up and down all the time. And that means that sometimes Bref is spinning up 10 containers, 20 containers for you to handle requests. Other times, it's spinning them all down again. It's going up and down. This container's handled 2 requests. This container's handled 200, depending on the timings they come in at. So you can't rely on anything local to cache your data. So that is very worth bearing in mind if your application is heavily relying on something like that. There are ways around that. We're not going to go into those during this talk, because one of the ways around that, AWS literally released 2 days ago, which is a system called EFS, which is a network file system. Used to be super slow, now apparently less slow. So I've yet to experiment with that, but I'm in talks with the developers of Bref to see what we can do with that at the moment. So local file system is a no-no. That also does mean if your application is reliant on storing your user data, on WordPress, I'm looking at you mainly, but a lot of applications, image uploads, file uploads, even sometimes actual data uploads in the form of JSON files. You won't be able to do that on Bref. You'll have your users sending data, and you'll be like, oh, look, they saved that image, and then 2 minutes later, the image is gone because that container died. So you'll need to store your data somewhere else. And really, if you're doing anything cloud native, you should be storing data in something like S3 or an equivalent object store in your own platform of choice. So that might be one of the bigger challenges for most people to migrate, would be data storage. So the other things we've had to change are, if I go back, you see, I'm not really following this because I know it, but all of the stuff I'm talking about is in this README. So again, if you think I've gone too fast or you just zone out for a moment, whatever, you should be able to catch up on everything in the README. It should read just like an article on the whole process. Yeah?
You said like we should be storing like outside the network. Can we use the Bref, right, just to like push the thing right to the S3?
Yes. Yeah. So we.
PHP, right? It's not like the node kind of things where the binary kind of like packet come right and then throw it. But first of all, right, everything needs to be posted. Let's say like one endpoint. We got one endpoint, right? First of all, that needs to be uploaded on the Springboard, which in this case is Bref kind of container, right? And then from there to wherever the S3 is.
Yeah.
During that particular, like let's say we got like really big file, right?
Mm-hmm.
Is there any tendency to lose that file kind of chunk?
Yeah, so for anyone who didn't hear, or for people on the video, we're talking about file uploads, and not just where we store them, but how the actual upload process is handled. So thinking things like multi-part file uploads would be a big example of that. So if your users are uploading sort of smallish files that can go in a regular HTTP request in a single go, you'd be able to handle them fine in Bref. You can, again, because the FPM container is acting just like you running PHP on a regular web server, you'll have your underscore files super global. So if you use simply a Laravel, we'll pull a files object out of that for you, and you'll be able to store that file anywhere you would like to. So you could use the AWS SDK to write that to S3. If you are handling things like a big file upload, so someone's sending you a couple of 100 megabytes or a couple of gigabytes of data on your website, I would recommend not trying to do that via your Bref application directly. What you can do is a system in S3 called signed URLs, pre-signed URLs. So you basically access an S3 API call, which gives a URL direct to S3, which allows someone within a small window of time to upload a file directly into your S3 bucket. So you would program your front end to sort of make a request to your back end, get that URL, and then use that URL to stream the data directly into your S3 bucket. Do be aware that obviously what that will mean is that the user can send pretty much any file they want to the bucket at that point. So you probably want to have then some sort of secondary processing system to check that file's the right file and isn't something weirdly malicious. Although again, because we're not talking servers anymore, someone uploading a malicious file to your S3 bucket is a lot less of a risk than someone uploading a malicious file to your web server, because it's on an S3 bucket. They can't do much with it. If your application then naively pulls it down and executes it, then you are a braver person than I am. But in general, that's going to be a safer process anyway, even if you're not running serverless. That's going to be a safer process for big file uploads, rather than your web server holding a connection open for a very long time to take a huge file. Has a bunch of things that can go wrong with it. So AWS provide that infrastructure for that reason, so I would say leverage it if you've got the opportunity to anyway, whether or not you're doing serverless. So the other thing we want to look at is the middleware, and this is in somewhere in my application app here. Middleware, we've removed sessions. We've removed sessions because natively PHP handles sessions by saving to the file system, and we've already said we don't have a file system. You could create a really confusing experience for users by storing sessions in /temp, and then they'd have a session one moment, and then when that container goes down, they've lost the session again, and they just have to keep logging back in, and you just say, oh, it's your browser. You probably wouldn't keep your users much that way. There are other session storage you can use. So for example, AWS DynamoDB, which we'll talk about in about half an hour's time, can be used to store sessions. But what I'd also recommend if you're looking at a sort of cloud migration is not storing sessions at all and using a sort of stateless user storage, such as JSON web tokens, where you can store the user's state, their user ID, in a token that you sign so that they can't manipulate it. And then that's just stored in a cookie that gets sent with every request, and you can kind of revalidate them. JSON web tokens can have expiry times, so you can say this person's authenticated for a certain amount of time. They're a great tool. do be aware if you start implementing JSON Web Tokens, you can't just dump anything you used to dump in a session, because the JSON Web Token, whilst it looks like a load of random characters, can be decoded by any user. They can't change it and send it back to you, but they can decode it. So don't store sensitive data in a JSON Web Token. Just generally the data needed to identify a user, maybe identify some roles or scopes they have access to, like you would with an OAuth API. So yeah, sessions, generally a no-no with Bref and serverless in general. So the other thing we want to look at is in our settings. A very small change we made here. Slim's standard skeleton sets up a logger for us, which is great. One change we had to make is the logger as standard output to standard out, which was fine for a native Slim framework app. But on Bref, standard out is the stuff that's going back to your user. So if you log to standard out on Bref, you will send your user your log streams, which is not generally recommended. So instead, you need to switch it to standard error. So even that seems a bit weird, why do all my logs go to standard error? It's just the way that Lambda works. And then if you send all your logs to standard error, you'll be able to view them in Amazon's CloudWatch logging tool, which has actually gotten pretty good since I last talked about Bref. They've added like a querying language. They're at their own querying language, which is a bit annoying. You've got to learn their querying language to query your logs. But it's kind of cool that you can make your own queries, save them, and slice and dice your logs a lot more easily straight from your application, which is quite cool because if you're just running a standard application on an Apache server somewhere, chances are your logs are just going into a file. And if a log goes into a file and nobody ever reads it, is it really there? Or at the very least, is it at any point or use to you? So I've known developers to sort of, a bug happens and months later they say, oh, it was in the logs. Well, that wasn't very helpful for you, was it? So yeah, having your logs easily accessible, easily searchable is actually an advantage if you do set this up correctly. So those are all the changes we've had to make to our application from a standard skeleton application of the Slim framework to run in serverless. As I say, if our application was doing a lot more work in terms of SQL databases, in terms of storing user data on the file system, yes, we'd have to do more. But the other side of those things is, especially things like file system storage, I would probably be moving away from that anyway, no matter what platform I was on. File system storage just has a bunch of risks and a bunch of issues and things that can go wrong. The number of systems getting ransomware attacked, etc., is growing. And yeah, I think if you're storing any important data on a file system, you're just sort of rolling dice as to your security posture and the resilience of your data these days. Platforms like S3 and the equivalents from Azure and GCP are there for a reason, and I would recommend people use them whether or not you're going to do anything else in the serverless space. We're now going to deploy this to Amazon Lambda because that's the whole reason we're here. We're here to see the deployment process as well. And for that, we want to install serverless. So if you haven't yet installed serverless and you have Node version 12 or above, you can type npm install -g. For those not familiar with npm, -g just installs it globally to your profile rather than to the specific project. Serverless. And serverless uses a serverless YAML file. The DevOps world decided a while ago that YAML was the thing it was going to sort of, the hill it was going to die on. So, everything in the DevOps sort of space is YAML. So if you don't like YAML, you'll have to sort of get used to it. And the default serverless YAML file will do most of what you need, although Bref, if you're running your own Bref project, has a Bref init function, which will create a Bref serverless file for you. To avoid having to type loads of things out and get them all in the right order, I've done most of it for you in this example. I'm just going to walk through a few factors in this. Firstly, the use.env here allows us to use our environment variables from our .env files, which is very helpful. Our service name here is the name of the service that's going to be deployed to our infrastructure. Service names need to be unique in your account. So if you are wanting to deploy multiple services, they need their own unique name or your deployment will fail. But it's only unique for your specific account. Provider, as I say, the serverless framework itself is agnostic. It can run on any provider. Bref will only run on AWS. So Bref is pre-compiled containers for the AWS infrastructure system. So if you want to run PHP on other platforms, you will need to find a solution for those platforms. As I say, the principles are the same, but the actual tool you use might be different. Your runtime is provided on Amazon Linux 2. I don't know what this means. Doesn't matter. It comes with it, and it'll warn you if it's wrong. Environment. So this is data that we're going to pass through to our function. So like any system, we want to actually give information from our environment into our function. So for example, things like private keys. There are other ways you could send secrets to something like Lambda. Do be aware, whilst obviously these keys are being sent from end files on your machine, so they are technically secure to you, these keys will be available in plain text for anyone with access to read your Lambda functions. So if someone can read your Lambda functions, i.e. A user in your AWS account, they will be able to see these environment variables. Depending on your configuration, that might or might not matter. There is a totally separate system in AWS called Secrets Manager, which is very powerful for actual handling of secrets. It costs more money. I think it's 40 cents per month per secret, plus extra for requests. So it's not super cheap, but it's good for a few API keys. Not necessarily good for hundreds of things. So anything super secret, you put there. So Stripe private key for a big organization might be such a thing. In this case, I'm assuming this project is going to be used by individuals deploying to their own infrastructure. Therefore, it's fine in this environment. The rest of these things are not secretive. They're just variables. Our plugin, which is Bref. If you have other plugins that you want to use in serverless, you can just add them here. And finally, functions. So as I mentioned, a lot of examples of serverless, you'll see a function per route. So if we have /setup, and we have /pay, and /complete, or various other endpoints, we'd have one block in functions for each of those with its own handler. Because we're using FPM, we are, no matter how big our application gets, no matter how many routes it has, we are still going to have one handler, index.php, and then this Bref layer. The timeout is important to note. 28 seconds. This is another thing that will prevent you doing something like huge file uploads. This will also prevent you doing things like huge SQL queries. The API gateway has a timeout, and you can increase that, but there are limits to how high you can increase that. Lambda itself has a timeout, which it used to be 15 minutes. I think it's now an hour, but still, limited process. If your web request is taking an hour to come back, I don't know what you're doing. But you might also be running Lambda for other functions, so image compression, something like that. I would always advise you to try and design a use case where, if you do something like image compression, don't run 2,000 compressions in one Lambda function, run 2,000 Lambda functions to do the compressions. That's often the principle you need to kind of re-architect your brain around from the world of running things in like cron or somewhere else. And then finally, events. We're creating a HTTP API. There are other events you can have, many types. We'll explore some more a little bit later. And we are allowing any endpoint to hit our HTTP API. So that means that no matter what the user puts on the path after your domain name, they will hit this index.php file, and then you can pass that request with a router like you're used to doing in any other PHP application. Finally, I've put here exclude files from deployment. That's actually not true. It's including them because I thought that was more sensible, because otherwise you add a file and you forget to exclude it, and then you deploy something you really shouldn't do. So we're just deploying a few setups here. So for example, we don't have to deploy our JavaScript here because we're not going to serve our JavaScript through our PHP application. That would be strange. So we are deploying, this base says nothing, and then our app, lib, vendor, and index.php files are going to get deployed. Let's deploy it. So we can deploy it. I've got the command up here. So yeah, a few factors. You'll need to first have an env.development file. So I've got my env.development local, which we already used, and then env.development normal here. And I need to configure. The one thing you'll all need to configure is this one. This will be used in just a moment. I'll zoom in. Sorry, wait. S3 bucket names are one of the unique things in AWS where the resource name has to be unique in the world. So you and I cannot register the same bucket name. The reason for that is that S3 names can also behave as domain names. So obviously people start doing things like registering google.com or other things as S3 bucket names. Not that Google is ever going to serve google.com from an Amazon S3 bucket, but it's quite an interesting way of squatting on people's domain names. If you don't want to actually own the domain, just create an S3 bucket with that domain, and someone can't ever use S3 to host that domain, which, it's an interesting move. One of the things people actually do with S3 bucket names is they watch for new registrations of bucket names by just randomly polling to see if they exist, to try and detect if people like AWS are releasing new services. So that can be quite an interesting thing. And there's a whole bunch of hacking stuff that can go on with S3 bucket names, which I have a separate talk about if you want to chat to me about it at some point. So bucket front end. So in my case, I'm prefixing it with my name, which, I'm guessing none of the rest of you will do that, or not use my name at least. That would be weird. and then Serverless Workshop 1, because this is the first part of this workshop. So you'll need to set that up for your own name or your own namespace. Now we're going to deploy, which is going to create a bunch of stuff. So we run this service deploy, stage development. So we're only going to deploy development stages today, but you can imagine that you might have stage development, staging, production, whatever you want to call it. The word development here is nothing special. It's just a word I'm using for my environment, and it just maps to my env file. So I could do stage chicken and then env.chicken if I wanted to. It'd be weird to do that, but there we go. So serverless or SLS, deploy stage equals. Do be aware that if you put a stage that doesn't exist, it will still just happily deploy for you. So do check your spelling when you are deploying things. I actually have like a little script, a bash script that I just use because, as you may notice through this workshop, I'm a little bit clumsy when it comes to typing. Actually, it's failed. It's failed because I've not got any AWS credentials. I use lots of different AWS accounts, and so I use a tool called AWS Vault to access AWS. So I just actually need to log into that first. And now I have credentials. Depending on your environment, AWS Vault is fantastic if you have anything sensitive in your AWS account. So if your AWS account is for anything other than you messing around personally, I'd recommend Vault, especially if you have to have accounts for your personal use, your other personal use, your company use, etc. AWS Vault is great. You run it and it just loads credentials into your local shell, and then if you exit that shell, there's no credentials. So random programs running in your terminal can't snoop on your AWS account, which is fantastic. So this time it will actually work. So you can just put keys inside the M file. That's definitely one way to do it. What I would normally recommend is not put them in the end file because this end file is going to your application deployment. So if you make a mistake with that, you end up uploading your keys, which are, as I said, uploaded in plain text to your AWS account, which obviously they're on your AWS account, but someone might not have read access to your keys, but they might have read access to your Lambda function. Now they have your keys. So I would generally store your AWS keys somewhere else. But AWS will, by default, check for a few locations. It will check in your environment, so you can just do an export of your key into your environment. You can store them in your home directory in .aws/credentials. There's a whole range of places you can do that. AWS have a website just for local credential storage. But I would, if you haven't got any AWS set up at the moment, AWS Vault is definitely the best way to do it. It's just go on GitHub, you download a pre-built binary for your system. Just give it execute permissions, run it, and then you can add your keys into AWS Vault. Thoroughly recommend it. So you'll see a few things here. We've uploaded we've created a stack, and the stack is a term in AWS's system called CloudFormation. So CloudFormation describes stacks. That's their sort of key resource, and a stack is a collection of other resources that CloudFormation is managing. We have uploaded that file that defines our CloudFormation stack to S3. We have then zipped up our artifacts. So you see it's packaged them up. We're at 12.96 megabytes. There is a limit to how big these packages can be. It's 256 megabytes with everything all in, and that includes the Docker container that's running the layer. So that 12.96 doesn't include the Docker container. So you might find that you can hit a limit that's less than 256 megabytes, and then Lambda will still say, no, you can't upload it. Like a lot of things in AWS, some of these things I say will be out of date by the time I've said them, because a lot of limits are always going up. So for all I know, that might be higher by now. The last time I gave this talk, it was 256. And there we go. We've deployed. I'm just going to scroll back up again to go through a few of the more things we saw. So this is the point where This is the point where it will generally take a little while because it will create a load of resources for you. The first time you deploy a stack, it will take longer because it's got to create all the resources from scratch. Then you'll make some changes to your application and you'll deploy again, and the deploy will be much faster because it's not got to create an S3 bucket and an API gateway. It's just got to update some code for you. So that depending on what you're doing, this process can take a varying amount of time, but as you see, it's not a long amount of time either way. Once it's deployed, it tells you, so we've created 11 resources, which is kind of cool from the minimal amount of configuration we've written so far. That's all we've written, and we've created 11 resources. And it gives you an endpoint. So this is your unique endpoint for your application that's now deployed to AWS. We can test that endpoint out. We're going to run a curl request to it. And one thing to mention is all of the things in our application are defined to run at /API. You'll see why in a moment. And so if we want to do that, curl request to that. Whoops. Sorry, I'm not doing very well at zooming this. No, that's a fine button. Oh, it just exits after one go. That's frustrating. Hopefully that's fine. And there we go. We've made a request. I've given it all the verbose output, but the key thing is we have a HTTP 204 because I decided that the default API / would return a no content response, which is quite unique to, if you sent that to a URL that didn't exist, you wouldn't get a 204 from it. So we get no content back, but we do get a 204. And you see we've got an X powered by header, powered by PHP 7.4. And all our access control for if we're doing cross-origin resource sharing. And that is our application. And obviously, just like any application, we could write into our response any of the headers we wanted to send. Amazon adds some IDs to it. So this is API Gateway, which is Amazon's API system. So they add a request ID, which is very helpful to actually, your application gets sent this when it gets the request as a header. So you could then map your logs of things that went into AWS, things that came out of AWS. So if you've got front-end logging, you could then find that request ID to see how those things all map together in distributed tracing, which is very useful when you're running in a serverless environment to see how different connections map to each other. And we can see our application is, at this point, is working. We can't test our application yet, though, because our application has no front end. Our front end is still running on our machine, and we could remap that to point to our new API, but that doesn't really allow anyone to go online and make a payment to us. So what we're going to want to do is deploy our front end. And whilst this isn't part of Bref, and this is something that people have been able to do with front ends for a very long time on AWS, it's quite possible that as PHP developers who, to some extent, have been shut out of the serverless world, that we've not explored this part of how we're going to deploy front ends that interact with our backend. Ultimately, if you are having to deploy a PHP application to a conventional host, there's nothing really to stop you just putting JS files on that host and serving them from there. Why go to the point of creating a whole separate front-end serving system in a different environment to what you're normally hosting your website in? So we're going to deploy it to S3 and CloudFront. As I mentioned earlier, S3 can serve websites. You register an S3 bucket with the domain name of the website you want, and you can serve a website. This is a feature that was added by AWS to prevent people from just making their S3 buckets public, which led to lots of fun data breaches for everyone. And the only issue is that AWS do not support HTTPS with this way of hosting. So if you just create an S3 bucket and literally in the console, click Make Website, you'll get a website. It will work with your bucket domain name, but it won't be HTTPS. And maybe that's OK, depending on what you're doing. But it's not OK for our use case, because we're taking payments. We can't put up a HTTP site and say, hey, give me your credit card details. I promise I'm keeping them safe. So we need HTTPS. And the way we're going to do that is to tap into another part of AWS's system, which is CloudFront. CloudFront is a CDN provided by AWS. And CloudFront can be used for a variety of uses. One of them is caching content, so caching things like JavaScript and CSS files, if you are caching them from your origin. It can be used to serve content, like images from S3. It can also be used just as a way of putting HTTPS on something that didn't have it previously. You create an origin, you have CloudFront send a request to your origin, and CloudFront now has HTTPS. And CloudFront can generate a HTTPS certificate for any domain you want for free, as long as you own that domain and have it mapped in AWS. So we're going to do that and create a CloudFront distribution, which is going to allow us to upload our content to an S3 bucket, so our front-end content, and then have a URL at CloudFront that's going to be served from. Given we're doing this, I'm also going to solve another problem at the same time, which is cross-origin resource sharing. We've already seen that our application has to send all these access control allow origin headers, because we are going to be coming from an API, a CloudFront domain, and our API is currently on an API gateway domain. That could look a little bit suspicious to someone who is looking at your site. They go on mysite.com, and they make a payment, and they see this request to a URL like this. I would be suspicious if I saw a site that I was making payments to, making requests or something like that. Now, as a developer, we probably recognize, oh, it's Amazon AWS, but that doesn't tell us much about the owner of this domain. It doesn't tell us what it's doing. If I'm on a trusted site, I'm on my bank's website, and it's them making requests to that, I think something's wrong, and I stop what I'm doing. Maybe not everyone is security conscious, but we have to be aware that's a risk for people. So what we're going to do, given we're already creating CloudFront to serve our front end, is we're also going to use CloudFront to sit in front of our API as well. And CloudFront is going to serve both our API and our front end, which means that no cross-origin resource sharing is needed. And we have a single URL that all our requests are going to. So for users looking at our traffic, it's going to seem very legitimate for what we're doing. In this case, we're also going to leverage another factor of our serverless YAML file. I mentioned before CloudFormation. I'll actually show you CloudFormation and what it looks like. So here's a CloudFormation stack. And here's the stack I just deployed. And here's all the resources it created. I can see my event, so I can see what happened recently. So we told to create it. We created it. Some things completed. Some more stuff got created. Some more stuff completed. Some more stuff got created. And so on until it was all finished. And it's in a completed update status. And the way that this determines itself is I can look at a template, which, as you can see, is really easy to read. And this defines all my resources in AWS. Our serverless is doing a lot of heavy lifting here. Serverless is turning this into this. And aren't we glad it's doing that? But we can leverage some of the underlying CloudFormation systems to create other resources. So by default, serverless doesn't support CloudFront. It doesn't support creating custom S3 buckets. It doesn't support creating DynamoDB tables, which we're going to do a little bit later. Serverless just supports running functions serverlessly, because honestly, that's still a pretty big job, and it does it very well. What serverless does do is allow us to drop out of the serverless environment and run native CloudFormation code in the serverless YAML file. This way, when we deploy, not only can we deploy things that serverless can build for us, and therefore that we can run with Bref, but also that can run native operations and native resources directly on AWS resources. So we're going to copy, and I thought I'd give you a bit of work to do. We're going to copy a huge chunk of YAML here. And we're going to copy this into our, please don't scroll that slow. We're going to copy this into our serverless YAML file. It begins with resources. So I'm going to drop that in here. Do remember that because this is YAML, your spacing and indentation is very important. Many a problem with trying to deploy something to serverless has been solved by just checking where your tabs and spaces are in a YAML file. So just be aware of that, especially when you're copying and pasting code from places, because it can be quite frustrating. Like this, that I went to, yeah, there we go, we're good. Apart from that one. So resources here basically indicates, OK, from this point on, we're not doing serverless language. We're using native CloudFormation language now. What this means is that for anything beyond this line, the serverless.com documentation won't help you because this is native CloudFormation language. But it does mean that if you want to find out what to write below this resources line, you can go to the CloudFormation documentation. And AWS's documentation is very good. There is a lot of it, but it is very good and is pretty well updated. It's all on GitHub as well, so if you spot a problem, you can send a pull request. So in this case, we are defining two sets of things. One is outputs, which is going to give us some URLs at the end, and one is resources, which is going to actually build our system. I am not going to go through this whole thing because it's huge, but there are comments throughout which will detail what it's doing for you. Suffice to say, we are creating an S3 bucket to store our content at. We are allowing CloudFront to talk to our S3 bucket to get the content out of it. So this is our JavaScript and CSS for our front end. And we are also creating a CloudFront mapping onto our API so that we can have everything accessed under one domain via HTTPS. So I'm going to run this now. So literally having just pasted this big block in, I can run my exact same deploy from before, he says, with maybe too much confidence. One thing we will note when we do this is we can watch the actual process. Oh, your session expired. That's fun. Need an MFA token. I thought this wouldn't expire. I could put my MFA tokens up on the screen and see how fast you can copy them, but I'm not going to risk it. There you go. If you can copy that URL really fast, you get into my AWS account. And we're back. Okay, so this is also probably expired. There we go. Right, let's try this again. That was just AWS giving you all a bit of time to catch up. And in just a moment, we'll see that the serverless YAML file gets sent or converted into this language for deploying to CloudFormation. And there we go. We see we've got update in progress. So we get some new events. And we can watch these events. They're not necessarily interesting, although if you ever have a problem deploying, watching these events and going onto your CloudFormation page and seeing what it's doing is pretty helpful, because then you can figure out exactly why it is. Usually, in this case, I'm using an admin account on my own personal AWS account, so it's got full privileges to everything. Most problems when deploying stuff to CloudFormation or via serverless will probably come from your account or your roles, especially if you're doing this in your company. You might think, oh, I'm just going to add a CloudFront distribution, and if someone hasn't ever provisioned you with the ability to create CloudFront distributions because you've never needed to before, so you have to go to whoever manages your AWS account and say, I need to create CloudFront distributions, and you can have that conversation quite a lot of times. One challenge, obviously, with the cloud environment is with the number of resources we have. Keeping everything secure is a concern, and it's a consideration that people have to think about. We talk about a concept of least privilege, so give someone only the privileges they need to do their job. The challenge with development in the cloud environment is that the privileges we need to use to do our job can change daily. We think of this new resource we want to use. Oh, I want to start sending data to an Amazon Kinesis stream. Well, no one ever gave us permission to do that because they never thought we needed it, but now we need it, and it can slow things down a little bit. Obviously, the temptation on the other side is, oh, just give everyone admin. We're cool with that. One thing I would recommend if you're in an organization using AWS, especially if you're just getting started, is AWS can do a sort of inverse permissions, which is where you sort of say, okay, well, you can do everything but not do these certain things. And you can do that either with deny policies, or you can do it with a thing called SCPs, which I don't know what that acronym translates to. SCPs in AWS authentication and management will basically say, okay, this person can have any permission they want, but never this one. And allows you to sort of lock that down on people. Things like deleting databases, right? That's not a thing you do on a daily basis, deleting databases, or various things like that. Oh, I just want to delete the backups today. It's a casual job. I just want to delete all the backups. Like, you can lock down those kind of things and then give everyone more wide-ranging access. So that's one way to handle things. So we're still in update in progress. The reason we're still updating at this point is because we're creating a CloudFront distribution. And CloudFront is really cool. It is a content delivery service that by default is available in Europe and North America, and Canada, but can also be set to be available around the world. I think it's got three tiers of availability. When it's creating, therefore, it has to create in all these locations. So CloudFront won't tell you it's finished creating until it is available everywhere you need it to be. So any update to CloudFront can take sort of 10 to 15 minutes, which is like quite a long time especially when you're up front at a conference. But it's, in general, it's not a problem. It does mean if you configure CloudFront wrong, especially if you have a live CloudFront distribution and you make a mistake in your configuration, you will wait 15 minutes to find it's broken, and then at least another 15 minutes to be able to fix it again. So do be aware when messing with CloudFront configurations that if they're hosting a production service, maybe think about creating a second distribution first and checking that all works before you apply the changes to your live environment, or create a second distribution and roll your traffic over. Even though it is serverless and we think, oh, zero downtime, high availability doesn't withstand just making a mistake with the configuration. So be aware of that with if you start using CloudFront. So this is still creating. It's going to look great for a little while. So I'm going to continue talking whilst it creates in the background, because we've got lots to talk about. When this has been created, we will have an S3 bucket, which will be named with my bucket front end from my M file. So here. And we'll then be able to upload our code into that bucket. In fact, that bucket's probably already been created. S3 bucket, there we go. Yeah, so we've already got our S3 bucket has been created here, so that's done. So we can deploy into it, which is cool. So I'm just going to open a new tab to do that. So I've written a little script to deploy because it does a few things. It's building a React application. It's making sure all my envars are set, and then it's just going to sync it up to S3. So I'm just going to run that now. So bin deploy dev front. Must set React app API URL. Yes, we must do that. Oh, we can't do that until we have our API URL from here. So we won't do that just yet. So whilst that works, I'll mention something else on CloudFront. We're not going to go into detail on this because we don't have the time. But CloudFront is awesome as a caching service. You've probably all been told to use things like cache busting URLs and things like that. So you serve your JavaScript and say, oh, cache this for a year, but then you increment a timestamp after the question mark in your URL, and then the cache service gets it as a new file when you do a new deploy. Things like React, things like Vue generally build their systems to handle that by default for you. One thing to note is that won't generally apply for something like an index.html file, because by default, someone goes to your bare URL, and it will load by default index.html without anything after the query string. You can't change your bare domain to change which file it loads. It will always load index.html. And so if you update your index.html file, it will be cached for as long as you have your caching set up. There are two ways around this. One is to have very short caching times, but that's detrimental to your user experience. The other is a system called CloudFront invalidations, which basically means that when you do a deploy, you tell CloudFront, hey, forget this file. And I think you get 1,000 invalidations free per month. So you can do quite a lot of deploys per day before there's an issue with the cost of invalidations. Yeah, there's some code down here. I'm not going to go over it, but there's some code down here. If you want to start using automated invalidations in your deploys, use this code down here, and that will actually work for you. Whilst we still wait for that deploy to complete, oh, it's done. Hey, look at that. Good timing. So we can now look at our stack. Oh, it was faster than I thought. Well done, AWS. Done me proud. The AWS console is not the nicest for zooming in. We have outputs. So I told it in this section here to give us a CloudFront URL and distribution ID in outputs, and it did. And here's our CloudFront URL. So this is the URL that our application is going to be hosted at. So what we can do now is we can go into our env development file, and we can set our React API URL. And we can test it as well. So we can once again send a curl request to it, just like we did before. So the terminal open. So and there we go. There's our 204. So we can send that. This should not end with a slash. I'm glad I put that comment in there because I would have totally put a slash at the end. And then we can once again run our front-end deploy process. Which is going to build our React file, or our React application, into the build directory here. And then it's going to upload it. We should now find, if we go to this URL, our CloudFront URL here, we have our application, and it's live. And we should find also we can send data to it, just like we did earlier locally. Oh, something's wrong. Ah, I didn't include /API. The best documentation still doesn't always work. that is probably the caching issue I talked about. I think I have, by default, set up caching to be very short length of time. Yeah, 5 minutes. So we could just wait 5 minutes. We've got more stuff to talk about, though. So we have an application, and it's now running in a serverless platform. That's cool. We can take payments. We can send someone this link to this website, and we can tell them, hey, go to my website, put in £15, put in the description, ticket for Julie, and then send the payment to me. And then someone goes in and puts £5 and puts ticket for Boris. And you're like, why did you do that? And you realize people aren't very good at following instructions. And so for any real application, we generally need something more than just some compute resources available online. We generally need data storage. We've talked already about file storage, so storing things like images in S3. But what we really want is a database. And as PHP developers, we often describe ourselves not just as PHP developers, but maybe as LAMP stack developers, Linux, Apache, MySQL, PHP. That might change a bit. Maybe we don't go for MySQL, maybe we go for Postgres. Maybe we don't go for Apache, we go for Nginx. But it's the same concept. We associate ourselves with a language, a database technology, a server technology, and we kind of bundle them all together when we talk about what we do. And SQL development, and especially, to be honest, MySQL development, is very prevalent in the PHP industry. Most of our big CMSs are designed to work with it. Our key tools, Laravel and Eloquent and Symfony and Doctrine, are designed mainly around looking at relational databases. The issue is that we've gone to all this trouble to get ourselves on serverless. We no longer have to think about servers. Apart from we do have to think about servers if we're still using a database. If we're still using a SQL database, we still have to worry about uptime. We still have to worry about CPU usage. How much memory are we paying for? How much hard disk space do we have? Do we have enough of those things? What about downtime? How do we manage version upgrades? A wide range of things, really, that mean that all our thoughts about no longer having to think about servers, or at least thinking about servers less, is not true. We're still thinking about servers quite a lot, because we actually still have a single point of failure in our application. For most of us, the single point of failure in our live applications, I imagine, will be a database. If your database server goes down, I imagine that is the thing that is going to keep your ops team awake, or wake you up if any of you are sort of on that side of the business. And it's going to be the thing we have to manage, then we have to overpay for. And we have these spikes in our traffic. If you run a retail site, you probably have spikes around Black Friday now, Christmas, which mean that you have to maintain this hugely powerful database all year round, only to use its maximum capacity a few times a year. Maybe you can auto-scale your database a little bit. In AWS, you've got managed databases, so you can say, oh, I want more CPU power for a little while, but that might mean some downtime while you transition. It's not the ideal world that we were promised. And so we're going to look now at serverless data storage solutions. So this is where you can cheat if you are trying to follow along but have fallen behind. Git checkout step 2 will get you right on board with step 2 of our work tutorial today. So we've made some changes to our application because we want to be able to do something a bit better for our users. Rather than telling them go to this page and putting in £5 and a ticket for someone, we are going to generate them a link, and send that link to them, and that link will fill out the data for them. Now, you don't necessarily need a database to do this. There's other ways you could have done this. But this just gives an example of why we might need a database in an application, even a simple one. But again, we're building a simple application. Spinning up a SQL server, working out the load balancing, it's not something we want to do for this. So we're going to have a look at our payment repository, which we've implemented to manage this. So we're going to provide 2 functions in our API. The ability to send a payment, to save a new payment, and the ability to find a payment by its ID. And we can look also at the payments class. And we can see that payments have a few details. They have an ID, which is just a UID. They have an amount, a currency, a description, and a time that they're created at. So some basic data. And we want to store this data, and we don't want to have to worry about servers. So this is where DynamoDB comes in. DynamoDB is a serverless key value store. Key value store, simplest way to think of it as PHP developers is to think of an array in PHP. You have an array key, which can be a number, it can be a string, it can be a float if you're crazy, and then some value at your array key. And then you have essentially a map of keys to values. A key value store can also be something like Redis. If anyone's used Redis, you generally have a key, and you can put data to that key. That data is generally represented in something like Redis in the form of a string, although that string could be something like a serialized object. It's serialized via PHP serialize or via JSON. You get the point. Key, value. Very commonly used in caching, and often used in our internal code structures. We use key value stores all the time in development. And DynamoDB is a serverless key value store. So whereas with Redis, you have to set up a server that runs Redis, and again, you have to configure Redis. Dynamo, you don't have to worry about servers. Dynamo is entirely accessed via an API. So just like Amazon's S3, where you can say, save this file for me, and they save a file for you. With Dynamo, you say, save this data for me, and it saves some data for you. What's cool about Dynamo is that it goes beyond just being a key value store. I think if Dynamo was a key value store, we would have a really hard time building a database out of it. Because building a database out of a pure key value store is possible, but it's challenging. It doesn't suit every type of data access, and we are going to run into a lot of problems. Dynamo does not solve every problem of that. Dynamo, at its heart, is still a key value store, but it definitely pushes the boundary of what a key value store can be, and also what a highly scalable key value store can be. As an example, Dynamo can scale from any amount of low requests up to 40,000 reads or writes per second. If your application is generating 40,000 reads or writes per second, then I think you're doing quite well. And I also imagine that your SQL servers would find it pretty hard to process that kind of level of throughput. Anyway, Dynamo can also scale this not just within a single region, but globally. So you can be processing 40,000 reads per writes per second per region that you're operating in. And that's pretty powerful for a lot of applications. Dynamo also goes further in terms of how its keys are built. And this is the sort of real interesting part of what Dynamo does. Dynamo is a composite key system. A key is composed of a hash key and a range key. And the unique concatenation of these two keys identifies a row. So, for example, a row without a range key and just a hash key, I can only write one row to that hash. So if I have a hash key of 1, and I write anything to that hash key, that updates that row. So if the row doesn't exist, it gets created. If the row does exist, it gets updated. You can do like a safe write option in Dynamo. So it'll say, this is not a new row. I can't write onto it. So you can avoid accidentally overwriting data, which is handy depending on how you build your keys. Where Dynamo gets interesting is adding the range key. Because you add the range key, and it's now the composite of those two keys. So you can now have multiple rows with a hash key of 1, as long as for each row, the range key is different. But then you can do a fetch on Dynamo to say, rather than just give me everything with a certain composite key, give me everything with hash key 1. And now it gives you a list of rows. So it's a key value store that can give you multiple outputs for a single key. You can then also say something like, give me every value which has hash key of 1, and with the range key greater than 5. So you can start doing things like sorts on it. You can also do every value with a hash key of 1, but with the range key starting with the word the. And you can now do interesting parts of text search on it. And you can also say a sort by that range key, so sort descending or ascending by that range key. You can do greater than, less than, not, equal, and starts with. You can't do ends with, which is sometimes a little frustrating, but it's a pretty powerful system. And what this means is that at Dynamo, you can build tables that can take multiple types of data from your application, but put them in a single table. So where in SQL you would use something like joins to map data together, in Dynamo you could store a user and the user's product basket and the user's purchases in a single table, and use different formats of the combination hash and range key to determine what type of data is contained in each row. This is a little bit mind-boggling and I think deserves a full talk on its own. I don't have time for that today. But suffice to say that Dynamo is a lot more impressive than when you first look at it. When you first look at Dynamo, you think, oh, that's cool, I don't have to pay for a database anymore. Then you try and use it for a few days, and you think, I hate this thing. I can't do anything I want to do. I can't do any sort of searching. I can't do joins. And then after a while, you realize that most of the joins in your application could just be replaced by 3 sequential API calls. So I can just go get this row and then get the row that's matching to it and then get the row that's matching to it. And because the key value store in Dynamo lets you get a list of items per key, you can essentially create your own joining system by just doing 3 API requests. And in many cases, 3 Dynamo API requests from infrastructure within AWS will be faster than that SQL query because you don't have to worry about which keys are indexed and which indexes am I allowed to query on for this, and running explain on queries, and all those things that you generally shouldn't have to do, especially if you're building a transactional system. One thing that is maybe obvious that you can't really easily do with Dynamo is anything like free text search. I mean, SQL isn't particularly great at free text search. You can do it, but it's not a key use case. So free text search, subqueries, that gets a bit complicated. Anything analytics, if you're doing like analytics workloads, Dynamo is not the place for you. But there are other tools in AWS that can do that for you. So you could run Elasticsearch. Yes, that's back to managing servers, but often when you're doing analytics, your server uptime isn't the biggest thing to worry about. So your live application can be served by Dynamo, and your analytics, your business team, can run all their queries in Elasticsearch. If that goes down for some reason, well, they have a slow day. They go for coffee. But you don't have to. You don't have a production outage if Elasticsearch goes down. So there are a variety of ways you can use that, and we're gonna look at a few more DynamoDB features towards the end if we've got time. And the value, we've talked about the keys a lot. The value, what's the value? The value is a JSON document. The way that Dynamo stores JSON is it actually stores a sort of superset of JSON that can have a wider range of types. JSON is a cool language. It's very simple, very easy to express things in. It lacks a few things. One thing JSON lacks, especially for PHP developers, especially anyone who's been using static analysis in PHP, and parsing JSON, you have that thing where you expect like okay, I want a list of integers, and I'm doing strict comparisons or strict function calls on all of them, and then one of them just comes through with quotes around it. It's still the number 2, but it's now got quotes around it, and it blows my code up because it's not an integer. Dynamo can fix that for you. In Dynamo, you can declare a list as a list of a specific type, and then Dynamo will fail to write the record in the first place if it's got the wrong type into it. So then when you fetch that record back, you know that it's type safe, which is pretty useful. They also have a specific data type for binary data, which is very useful if you're storing anything encrypted. And again, JSON would just you'd write it into a string and just have to hope that it sort of comes out the right way at the end. So binary data and sets are useful extra features. And I do imagine that, I know there's been talk about adding a specific date type, which again, JSON doesn't have a date type, which is really frustrating for so many applications. There's been talk about Dynamo adding a date type as well. Some of the Amazon's other sort of document storage solutions have added date types into their specifications as well. So we're going to implement this repository with DynamoDB. Let's actually use it. So firstly, we're going to have to run Docker again because, Composer again, because we need to add the Amazon SDK into our project. What was interesting previously is even though we're running on AWS, we actually didn't have Amazon's own PHP library in our project because we didn't need it. We weren't interacting with the API directly from inside our project. We were just running it on AWS. So we can run that. Just run Composer install, and it's going to pull down a load of stuff for us. And we're now going to implement our repository. So we have the Dynamo payment repository file. Which is currently very sparse, and influence parent repository, and you'll see when my system finishes indexing it that it's going to complain at me because I'm implementing an interface and I haven't got the right methods for that interface. Any second now, PHP store, do your work. There we go. But luckily, some helpful person has posted all the functions we need in the README. We can copy this in here. And now we've implemented our interface, PHP Storm stops complaining, and we can have a look at what this is doing. We're going to go sort of backwards, so we're going to look at the put first. I don't know why I put them in this order. I should have put them in the other order, but never mind. This is a very simple operation. The repository gets a payment object, which is just an entity in our system, nothing special. And it calls the DynamoDB client, which we've dependency injected. And it's going to insert that. The way we insert it is that we generate some parameters. All of AWS's SDKs in PHP work by sending them an associative array of named keys. This is quite frustrating because it means that you have to have the names of all those keys to hand whenever you're developing. A fluent interface has yet to materialize, which is a shame, but understandable given how big their API is. So in this project, I've written this simple class with a bunch of static functions that is simple Dynamo utilities. I'll probably spin this class out as a library at some point. Because it's just handy to have something on your tool belt rather than having to use like a full ORM. Things like Doctrine do have integrations with Dynamo. I do think that in the same way as I reckon people should always write some SQL before using an ORM, especially if they're going to use something like DQL, you should probably write some Dynamo code natively before you start using an abstraction, because then you'll understand what you're doing and why you're doing it. Abstractions are great for actually using a supported library in production, keeping up with the latest features, etc. But I think that knowing what you're doing, in especially Dynamo is a proprietary database, there's only sort of one of a kind. Knowing what you're doing with it is pretty helpful when you're starting to develop in it. So we have an insert params. Dynamo uses this system called a marshaller. This basically takes regular statements, like a regular JSON string, and turns it into Dynamo's own format. Because we're still having to send it over the wire, we're still sending a JSON document to Dynamo. Dynamo converts your sort of Dynamo models with your sort of sets and binary data and dates or whatever Dynamo supports in future, and it turns it into a structure which uses keys to declare the data type, so it can convert it to regular JSON. So it means it's quite verbose JSON, because every item has to declare its type before it declares itself, which just looks awful when you read the JSON data. But it means that you can send it as standard JSON, which obviously makes just sending data much easier when you've got a standard format to send it in. So that's what the marshaller is for. So you give it an item, so in this case our entity, and it turns it into a marshaled version of that item that you can send as an associative array in PHP. We have a function from our entity that gains its table name, and that gets sent to Dynamo. In this application, we also, to actually run this, we also need to map up the DynamoDB client in our dependency injection, which I've left a little space for, just below our logger in dependencies.php, so we can get our DynamoDB client. The other side of our repository is obviously our find. A little bit more involved here, but very similar. We similar to something like Doctrine, where you'd pass a class name for fetching an item, Doctrine or Laravel. You have a find parameter, which takes an entity, which in this case is a class string. This is a SARM type hint. If anyone hasn't used SARM, it's awesome. Start using SARM. There's a talk about static analysis in PHP tomorrow, which you should go to if you aren't familiar with what SARM is, or PHP SAM. So in this case, we're going to find something. We have a string hash key is required. Again, in SARM, I should have probably typed this as a non-empty string, because an empty string wouldn't be a valid key. And then we have a nullable string, which is a range key, because as I said before, you don't need to specify the range key, but you can. This specific find is a little bit blunt. It can't do any of like greater than, less than, starts with. You could add a fourth parameter to this to sort of allow a type specification for your range key. This application is just using hash keys, so it doesn't even need to. So we have to use the marshalling to get our hash key and range key into the right format. We then create this set of parameters and an expression, say hash equals the hash key. And then we have the option to add a range key if range key is not nullable. And you can see there we go. Oh yeah, so we use, if the range key is a string, we say begin with range key. Although in the parent function, you notice that I made a mistake because I've said range key has to be a string. So there we go. Tighten up my API specification a little bit internally, but that's not a huge problem for this application. And as I say, I don't expect people to sort of be looking at this and going, yes, now I know DynamoDB. But looking through some of this code and playing with it will probably give you a relatively good introduction. The final thing we do is once we've fetched it, as I say, DynamoDB will always return a list. Even if it's one item, it will return a list of one item. So that's a worthwhile thing remembering. So we always grab the first item in our list if we're expecting one. So in this case, we're finding a payment by its ID. So we are expecting one back only, or nothing. In this case, we're throwing an exception. Obviously, you could also return null. And then we grab the first item in the list, and then we hydrate it into the payment object. So we take Dynamo's format of data and we map it. And again, the hydrator, I've implemented that as a trait, which uses reflection. That is maybe overkill for an application where I have exactly one entity. You could probably just write a mapper yourself to map your one entity. But if you're building an actual application, having an automated hydrator, it's the same as using an ORM. You wouldn't map up how every single database object maps to every single entity. You would use your ORM to do that. That's the same thing here. It uses reflection. So we've now implemented our DynamoDB system. And we want to test it locally. Now, local testing of MySQL tends to be easy. You grab a MySQL container. Same with Postgres. With Dynamo, it's a proprietary system. You can't download Dynamo to run locally. It's closed source. So, helpfully, AWS have acknowledged this as an issue with a proprietary closed source system. And they provide a way for you to test locally. They've built a DynamoDB local Java application. This is by no means Dynamo source code in a Java application. Don't think you can decompile the jar and be like, aha, I've hacked AWS. But it is an application which maps the API of Dynamo. So you can use all the API commands, and it should, for the most part, behave exactly like the real Dynamo would do. It will not scale the same. I haven't tried sending 40,000 requests a second at it. That could be a fun exercise if someone wants to do it. It will be interesting to see what it tops out at. But again, its storage and its capabilities are going to be limited compared to what actual Dynamo can do, but the API map is good, and so you can use it. The one annoying thing is it doesn't sort of do any helpful things for you. So if you want to put a table in it, you have to have a big block of code like this, if my scroll works, that sends a API request to this jar file as it's being built in Docker to create your table, which just makes managing your test data sometimes a little bit verbose. There'll be ways around this, but it's not the nicest. So in this case, we're going to copy this into our Docker file. I've created a Docker directory here with Dynamo. So we can copy it into this line where I've put build tables here. As you can see, it's a pretty punchy bit of text. The main thing you need to be looking at in this text is the key, so the key schema. So what we're saying, we've got an attribute name of ID. We've got attribute definitions. So this basically says, I want the ID to be my key as a hash key, no range key, and ID is a string. So anything that you use in your key schema, you have to define it as an attribute. S there is string, N for number, B for binary. You can't define a key as a set, because that would be weird. But yeah, you can use all the sort of scalar types. Ignore this line of provision throughput. Sorry, touching my microphone, not a good idea. Provision throughput is a principle of Dynamo as it existed through 3 or 4 years ago, where you had to, in advance, say how many requests per second you expected, which entirely defeated the point of Dynamo, but allowed AWS to launch it probably before it was fully ready to scale. These days, you pretty much want to be using on-demand pricing for Dynamo, unless you have a really good idea of your load. The only thing I can think of for something that would have such a good idea of their load is maybe something like an industrial automation system, where your output is really balanced over time. For anyone else, on-demand scaling is good. The provision throughput Dynamo does have auto-scaling, but often it auto-scales about 5 minutes after you need it to, and by that point, your application's already gone super slow. So I wouldn't try provision throughput in a live application, even though it can work out slightly cheaper overall. Finally, we're going to modify our test code. In our dependency here, because we need to tell it that if we're in test mode, don't talk to AWS, because we won't find it. We will instead be talking to, I've missed a line with my... If we're local, we're going to be talking to this, and we're going to modify our local environment as well. So msample, I've added some new stuff, new for step 2 in msample. So here. Yeah, and Dynamo tables, unlike S3 buckets, are not globally unique, so we could all use the same Dynamo table name as long as we're in our own accounts, which is handy. And for local, I need to just change this table to serverless payments. That's a lot of typing. Hopefully this is all going to work when I run it. Just going to terminate my npm process and start it again. Moment of truth. And you'll see that unlike before, we now have a unique ID in this URL. So this has made a request to my DynamoDB database and stored this. We can prove that by the fact I can open this in another private browsing and access the same data, which loads from my backend. So this is now creating a payment and saving to DynamoDB, and when we load it here, it's loading from DynamoDB. And if you want to explore the actual process of going through the code to do that, you can do. Ultimately, it's just a PHP application. You probably know PHP, so you can run through that yourself to sort of see how that process works. But the key thing is that we've built a DynamoDB application, and we're able to send data to it and query data from it as well. Finally, we want to deploy to AWS. In the same way we deployed our CloudFront distribution, we're going to deploy Dynamo. And I'm going to copy this block into my serverless YAML file. Note the indentation that we're starting a little bit in, because we're going to be adding it to this big, huge block of resources we've already got. So I'm going to add it at the top to make it a bit simpler to see where my indentation is. So adding it there. And it's complaining, oh, Dynamo key is duplicated. Oh, look, I already added it down here. Oh, well. Let's not do that then. Thank you to my IDE for telling me that I was doing something silly. I already added it to the, obviously I committed that when I was writing this. So we have a definition, very simple, and you'll see the exact same things that we just saw in a Docker file, but in a much nicer to read format. We have our table name, we have a billing mode, pay per request, define our attributes, define our key. And so now we can deploy that. And this is going to create our Dynamo table and deploy our code so that we can actually send requests to our Dynamo table. End Dynamo table could not be found. Oh, I've not put it in end of Dart development here. I need to copy it into here as well. So in our env.development, we remove the endpoint because otherwise it'll try and look for a local endpoint, which is not what we want. And we have our Dynamo table name. Interesting, it's going to find it fun when it gets to the actual defined Dynamo. I'm just going to cancel that. Let's do that again. And that's DynamoDB. We'll see it load live in a moment, hopefully. One other thing we do need to do. Did I copy this in advance? You see, so inconsistent. One thing with any AWS service we want to use, so S3, as we talked about earlier for file storage, DynamoDB in this case, or any other AWS API that we want our application to call, we need to think about those permissions again. We talked about your own permissions and your own user permissions to build something. The same permissions apply to our functions. And this is cool. This means that a Lambda that's solely intended to query DynamoDB can't write data into it or delete data from it, which is great when you are trying to build a secure application. It means that you can have an application that can query one table but not another one. I can write to this table but only read from that one. And various other ways of ensuring that your systems have the right privileges. This means that someone discovers some form of bug in your API that they could send a request to that maybe is unauthenticated. The attack service is limited. They find, oh, I can send a request to this endpoint, but all I can do at this endpoint is add new rows to this table, which is it's not the most disruptive attack they can do for you. So maintaining good privileges is very important. So in this case, we're giving our function the permission to do quite a lot of things on this one table. And again, you can probably see we've got little things like stars, so these are wildcards. So you could go resource star, and then DynamoDB star, and I can just do everything on DynamoDB. That would be a bold move. Because, again, then some bug happens in an application and a script that's just meant to pull a bit of data wipes your database. But it does mean that you've got really good permission configuration and control from within your deployment script. This is something I like about the whole way of doing things in AWS versus, say, a SQL database. In SQL, you would do a lot of what we're doing here, like creating tables. You'd generally do it via migrations. So you would change something in your ORM, you would then say, I want to create a migration from version X to the new version. And that would say, OK, this migration is going to create a certain number of tables, or it's going to delete tables, it's going to update fields, maybe it's going to rename things. And most migration systems come with a down option. So you can say, oh, the migration went wrong, right, delete that table, delete that field, which I always feel is super dangerous to have in anywhere near production infrastructure, because if you are running migrations up and down, and then you run a migration up, and then some data goes into that table, some user data goes into the table, and then you run a down migration, which deletes the table, that's destructive. That's data that's just been lost. You rename a field, and suddenly your application doesn't talk to the right field. I think that the idea of migrations is maybe something that doesn't really work with sort of high availability, high scale systems. What I like about using Dynamo, again here, is in the same place I declare my functions, I can declare my data tables. So I don't need to think about migrations. In the same move where I deploy the new version of my application, I also deploy the resources needed to create it. And I deploy the permissions for that. And if anyone wants to see, oh, what tables are in our application? There's one place to look. If anyone wants to see what permission does this function have to access certain tables, there's one place to look. They don't have to go into SQL and look at the grants for a specific user and a specific table. I think there's some real benefits for sort of resilience and security in building things like this. Not to say someone couldn't write something that would do this kind of work and deploy tables into MySQL, but as far as I know, no one has. Or not in the sort of serverless YAML format anyway. Hello. Yes. So for those who didn't hear the question, you've stored an object in Dynamo. Your application evolves. You add a new field to your entity, and then you start storing that field for new objects. But obviously, all your old objects are still there. Dynamo, because it's a sort of key value store with JSON documents, is schemaless. So I don't add a new field. So only objects with a certain key will have that key. So yeah, a key thing to remember is that when you are writing an entity beyond the initial time you've deployed it, you will want to ensure all your fields are happy with being null. So if you require something like a version, so this is one common way of handling this is versioning. So you can, in your entity, declare a private const, which is the version of you're currently at, your latest version. Each time someone makes changes to that entity, adds a new field, then they have to increment that version string. That way, your application can do intelligent checks on the entity itself. So, for example, an entity you might implement, you used to store name, and now you store first name and last name, right? So then your entity has a getName method, which says if version is greater than this, return first name space last name, else return name. So you can kind of, again, add the evolution of your data into the system. One way you could handle that in terms of how you handle something like a migration, you wouldn't generally want to, but say you went, oh, actually, there's only 10 entities with this version. So you could actually have someone just go and manually edit them, or you could write a migration script which used an index to pull all the items with a certain version and update them. Generally, I would just say try and handle that in your application. Most of us will find that our entities in development, our entities will evolve quite quickly. Once things are in production, we tend to find we add new entities more than we add loads of stuff to existing entities. The sign of sort of an entity which has like 50, 60 fields is sort of generally like an issue of kind of feature creep. It's an issue of leaky abstractions. We've got if you've got 1,000 entities in your database and only one has a certain field set, that seems like a weird concept to have. That feels like you should probably build a different entity. But the advantage of something like Dynamo is you can do that if you need to. If this one entity sometimes, I don't know, maybe it's a customer with a really weird requirement, and you just want to implement that for them, and you don't want to have to think about something. And in a SQL system, you'd have to add a new field to a table that's null for every single row except one. Whereas in Dynamo, you just add this field to that one person one time, and you handle it, and you comment in the code, okay, this is for Bob, who's just a bit annoying, and we added this. And then you've actually, again, you've mixed your business domain with your data and your code in a way that's completely transparent to everyone, which is pretty cool. We are going to... this isn't deploying. Why is it not? Service Workshop 1 already exists. I didn't change something. What did I not update? I didn't update. See, this is our whole, there we go. Globally unique bucket names. they'll be the death of me. So we're going to run the stack again. Finally, hope this works. Whilst that's deploying, I'm going to move on because I don't know how much time I have left. I think I probably have about 20 minutes. Can someone check your program and tell me when this is going to finish? Whilst you do that, the next thing I want to talk about, the final thing we're going to talk about is control flow. In that, if you're using serverless and you're using all these systems that are plugged in together in AWS, you may want to consider how you are allowing applications, parts of your application to talk to one another. In the case of our Stripe example, we have webhooks. Webhooks are great. Webhooks are ways of a third-party service notifying you that something has happened in their environment. That's usually asynchronous. So if I'm charging a credit card, generally I can expect the provider to return to me that this credit card is chargeable within a short period of time. But actually charging it can take a little bit longer. Actually knowing if the money's really come through can take longer again. Knowing if the money's been paid to my account takes even longer, maybe weeks. And knowing if someone's requested a refund or charged it back or disputed it can be anywhere up to months. And so the provider will need to notify me about this and send me a webhook. Stripe, I've one of the better webhook implementations I've seen. If Stripe send you a webhook and you miss it, they will try again, and they will try again, and they will keep trying again. They will use exponential backoff, so they will try less frequently over time. With Stripe's console, you can go and see all your failed webhooks. Stripe will email you if your webhooks fail too much. They are genuinely a great API to work with. That's not the same for most businesses. Most systems that do webhooks might send you one and ignore the return type entirely. Some of them have really weird things like very short timeouts, so that if you don't respond in about 2 seconds, they send it again. And that can be an issue if your site's under heavy load or you have to do a database call or something. Sometimes they will send one, and it doesn't matter what response code you return, or even if you're off the internet, they'll just go, yeah, we're fine. Fire and forget webhooks. So if you're relying on webhooks to tell you about how a system works, and you miss a webhook, you might be in trouble. Someone disputes a £1,000 credit card payment, and then you mail them the laptop they've just ordered. There is an issue. So we need to be able to know that we can robustly accept webhooks. But so many things could go wrong with processing a webhook. I might have a logic error in my application. I might have a downtime with my data storage. I mean, if I'm using Dynamo, hopefully not, but maybe I'm still bound to a SQL system. I might have various other things that go wrong. Maybe I've just, say, made a mistake somewhere, and we missed the webhook. If we miss the webhook, or we double process the webhook, things can go wrong. So what we're going to look at in this last step is Amazon's simple queue service. I'm just going to power on through here rather than making sure my previous thing finishes building. Hopefully it'll work. Anyway. Git reset before we check out. Step 3. Once again, beware, huge chunk of YAML incoming. Webhook storage is a way that you can say a webhook comes in and you store it somewhere and then you can process it at your own time. Strangely, there's no sort of off-the-shelf service to do this, but with a sort of mix of bits of Amazon infrastructure, you can produce this yourself. So Amazon have SQS, which is a queue service. Queues are great ways of processing data. You say, I want to do these things, and I want to do them in this order, and you put them in a queue, and then you have something like Lambda, watch that queue, and pull items off it and process it. So queues are great for when you think that you want to do 1,000 things in Lambda, but you only want a couple of Lambdas running at once. So then rather than spin up 1,000 Lambdas, you just put 1,000 things in a queue, and Lambda just picks them off one by one. Queues are great for things that have to be processed in order. So if you are processing credit card information, you probably want to know that the credit card charge has succeeded before you get a second webhook saying that the customer has disputed it. If you get those in the wrong order, things go wrong and confuse with your application. And there's various places that can happen. So SQS is Amazon's queue service. Again, it's serverless. It exposes a HTTP endpoint. You can literally get, depending on how you configure your queue, you could just find your queue's URL and just send data to it, and just as JSON, and it will just save your data. And so this is a great way of handling something like webhooks. You put your webhooks in a queue. It will always take the data. It will always accept it. It will always store it in the queue. And then if your system fails, you can handle that within your queuing environment. So you can retry it. You can drop it into a second queue that says, oh, this is a queue for failed jobs that a developer's got to look through and find out. It means you don't lose data. This is great for webhooks. It's also great for other examples. I think a big one being email sending. Email sending can go wrong in a bizarrely large number of ways. So again, in our platform for my company, email sending happens via a queue. The application says I want to send an email. It puts something in a queue, and that queue can fail in various ways if people's SMTP servers are configured incorrectly, things bounce, attachments don't load, etc., etc., etc. But it means that we don't lose those emails that we meant to send to people, and we also don't leave someone hanging on our web request waiting for an email to send in the background that, if they're honest, it's not like they needed to know that second that the email was sent, right? If it was a few minutes late, people are probably happy. Email's a bit like that anyway. So for anything asynchronous, basically, queues are a good thing. One thing we do find, if we're sending data to a queue, is we do sometimes need to reformat things. Stripe will have a different webhook format to another payment provider, I don't know, say GoCardless. And everyone will have different ways they handle their webhooks, everyone will have different ways that they work, different ways they process them. So in this system, we are going to create a custom API gateway endpoint, so a separate URL to our main application. And that's going to use a little translation that's going to translate an incoming webhook into an SQS entity and save it in the queue. And this way, our application will be able to process that entity afterwards. So another big block of YAML. I do think I'm running short on time, so I'm not going to go through and implement this entire thing for you, but I would thoroughly encourage you to implement this yourself afterwards. So we can. No, I reckon I can. Let's do it. Let's go for it. Because I really want to show you sending a curl request to it. It's the world's most exciting curl request. It's not. YAML, get your indentation right. Oh, is that complaining about me? Some validation is wrong. Seriously, YAML, what are you doing to me? Right, we're going to switch that back to 2 so that it doesn't have to write a whole new stack. So we're running another deploy here. And this should deploy our queue. So the reason we deploy this webhook API is that we get a separate URL. We put that into, in this case, Stripe. Or we're just going to make a curl request to it, I think. And we will then be able to see that appear in a queue. And then we'll be able to see how we handle it. One thing I mentioned earlier is that Bref has 2 processing tools. One processing tool that Bref has is the PHP FPM container. Another processing tool that Bref has is the just native PHP container. And the native PHP container works much more like any other Lambda function in any other language, in that you declare a function, so you return a function to Lambda, and then the incoming data to your system gets processed in that function. So I'm going to skip off whilst that deploys. So we actually, in this case, are going to produce a new function in our functions list, so we're not using our index.php anymore, because our application isn't processing the webhook. Because again, why have our application have to write code to take in a webhook and save it somewhere when AWS has the tools to just do that for us, and again, remove another failure point from our application, getting something wrong, and once again, losing the webhook, which we've decided is something we are not happy with. So we can add a new function. And in this case, we're calling it webhook. So these are just names, by the way. API and webhook are just, they're nothing special. They're not keywords. They're just names that I can give it. We have a handler, webhook.php, which is here. And webhook.php is basically, I've gutted the sort of top part of the Slim framework, and I'm returning a super simple handler. It gets an event. This event can actually be a little more decorated, because we can decorate it as an SQS event with Bref's SQS event package, which is nice. And all it's going to do in this case is it's going to say it's received the webhook from the queue, it's going to log it, it's going to log the data, and it's then going to log this serialized context data. The context data tells us things like where this event came from, when it appeared, which user added it, and other things that might be helpful to know when you're processing some data. And you see the difference here, that the layers here is Bref FPM. The layer here is 7.4, not FPM. You could use a different PHP version if you wanted to here. I don't quite know why you'd want to. That might confuse the rest of your application, but you could do. And if you want to do this kind of function work, this is generally where you will have one function in your serverless file for each thing your application wants to do. So if you have 5 queues that are doing different things, you'll probably have 5 handlers here. And what we see here is that the events are different. So where above we had a HTTP API, which took in any path and passed it on to the function. In this case, we have the SQS event. We give a batch size of 1. That means that the Lambda function will get 1 event from the queue, process it, and then exit. You could increase this batch size, so you can process a number of events at a time. In our case, the reason we want to only have 1 at a time is if our function fails, and I'm talking like a hard failure, so like a PHP type error that just kills our script. If we take 10 items and we have a PHP type error, we don't know which of the 10 items have been processed. So we want to be able to actually manage that better. So we're taking 1 item at a time in the batch. And then we use this little get at is a CloudFormation keyword, which basically just pulls the data, the ID from our generated queue below. And what that means is anytime an item gets added to our queue, this handler function will spin up a container and execute the function for us and do something with it. If it succeeds, the item will vanish from the queue. Queues aren't data storage, so the item will go away from the queue. And if it fails, the item can be dropped into what we call a dead letter queue, so for things that have failed, so we can go and retry them. One thing to bear in mind with queues and SQS, queues have to have really robust APIs. Queues are intended to deliver things like only once message delivery and in-order messages. If you add something like a meta layer to a queue, where a user can look into the queue without affecting it, a lot of people are going to start using that meta layer instead of using the actual queue interfaces and compromise the whole point of having a queue in the first place. Oh, it's too awkward to get my items in order. I'm just going to look into my queue and pick out that one item and do something with it. But now that item's also still in my queue. So in the AWS console, you can view a queue, but you viewing that queue counts as the item coming off the queue, which means if you view your queue, it's a Schrodinger's cat situation. By viewing your queue, you affect it. So if in this situation, we've configured our queue to only do 1 delivery of a message, if you view your queue, that counts as your message being delivered. And so your message will then fail as if it had failed in your Lambda function and go into your dead letter queue. So be aware of that if you're sort of going in a production environment and you're snooping in your queues, going, oh, what's this message? By viewing the message, you will cause it to not get processed. That's really the only way you can do that with a queue. If you sort of think through it in your head, you're like, oh, no, but I can't. No, I can't, because any other way, some developer somewhere will find a way to subvert any sort of meta API with your queue, any sort of logging API with your queue, and find a way to process things without taking out the queue, and leads to all the problems that queue is meant to solve. So that's a bit of helpful information about queues, because it's kind of good. You go onto the Amazon console, and I think we might be able to do this at this point, because I think it's finished just deploying. And we can go on to our queue, which should be down here somewhere. Here's the queue. We can't click through to it. Fine, we'll just go to SQS from here. And we go onto our queue. Can you tell I've been deploying a lot of queues lately? Service workshop development queue, this one. And we can just click, let's just receive all our messages. Let's just poll for messages. And right now the queue's empty, so there shouldn't be anything in it. But it's very tempting to go and do that and just see what's in my queue, and then I don't realize that I've affected it. And so I poll for messages, and then I walk away and do something else, and then we realize our system's lost data because I've just polled our queue and it's dropped into dead letter queue. So you want some sort of alerting on the dead letter queue generally as well. So if something's in the dead letter queue, something somewhere in your infrastructure should tell you that. Or you make it someone's job to check every day. We're going to post this queue. So the super interesting JSON. And we check our, we need to check our output on CloudFormation to get our queue URL. There's a lot of moving parts to this, so I would recommend, if you are at all interested in implementing this, go through the README bit by bit and run everything, because it can seem quite overwhelming and what on earth am I doing? but you will actually find that it makes a lot of sense after having a look at it. I need to run. It's not output my queue URL, which is fine. CloudFront URL, API URL. I don't know why it's not output my queue URL. I'm very upset by this. We could send something to our queue, and it would do something. I'm just going to send an item into my queue directly. That'll work. And then we'll probably finish. I can hear some people shuffling in their seats. We've probably done enough. So send a message. Let's just send our fancy JSON. Test 1. Send message. Your message sent, ready to received. Let's go to Lambda and see if we've received it. So we can see our Lambda here is hooked up to our queue, which is cool. And we can go into our monitors, and we can view our logs. No log streams yet. Is that message in my queue? There we go. Don't know if we've had any messages. Well, I've not had it received yet. It should have been received. Maybe it's just a lag in the data updating. Or maybe I've got some permissions wrong somewhere. This is the classic thing with all this, is that you might end up with permission errors or something else in your system. I'm just going to quickly check back if I've missed something. I am going to guess that somewhere on the line I was meant to add something to the IAM role of one of my functions to load something that they are no longer loading, or that this whole block, which seems to be weirdly yellow in my highlighting in my ID, is causing a problem somewhere. But I am not too sure about that now, and I think the least fun thing for you to all do now would be to sit there and watch me debug this. So I will probably have a go a little bit once we finish the workshop, and then post a video of me triumphantly posting a message to the queue afterwards to show you all that I'm in business. So what have we learned? We've done a lot. We've covered a lot. I've been talking for a while. You're probably all ready to go and do something else for a while. If you want to finally implement this, the full part of this system, you could copy this in, and this will actually update your database based on the payment that you are doing. So I decided to do a simple thing, which just updates a counter on the payment. But you could use this to send a receipt or mark something as paid, or trigger something other system to send a ticket or the person's package to them. Whatever you wanted really at this point. And obviously there's nothing to stop a process like this putting another thing in the queue, which is picked up by something else, which is then put something else in the queue, and you've just built yourself a very simple little microservice architecture. And of course, a lot of this can also be tested locally. So there is a Docker file for SQS. I don't think I've implemented. No, I've not implemented it here. But there is a open. It's called Elastic Queue, I think it is. It's a sort of simple implementation of AWS's SQS API in a Docker container. So that's really good for testing the queue out, making sure that all your logic and the way you think queues work actually works that way. And that would allow you to do things like take webhooks, like schedule email sends, and really just anything that you can put asynchronously into your system. And there's a huge number of things, even in the scope we've talked about here, that I've not mentioned. So DynamoDB can have not only queues, but streams, so they can stream data back out. So you can call Lambda functions on that data. You can have a stream on updates, a stream on inserts, a stream on deletes. We've got applications where something gets inserted, and that causes a stream, and that writes some new data, and then we've got another stream on an update. And You can tie yourself in knots with these things, obviously, but you can also build things that are very powerful, very robust, very fault tolerant. With queues, be aware of things like if you do need to retry a queue job, you don't have queue jobs that do multiple things in them, because if you do something like update a database, then send an email, and the email send fails, if you retry it, you'll update your database again, which might be okay, it might not be. So with queues, you want to think often about doing one thing that's kind of active, and then queuing another thing to do the next thing. So it's very worth mentioning for people who haven't used queuing systems before. And again, the great opportunity with serverless, building things in Lambda, is that you can try these things that you might not have tried already. You know, you might not think, oh, I've got this big application on our monolith, our LAMP monolith, and I want to use a queue, but all this stuff to set up. Well, move into the world of Lambda and Bref, and even for those things, you can just try this out. You can try it out in a dev environment. You can just build something, run it, test it, see if it works, and have it in production relatively quickly. As I say, there's some things you might have to change your application, especially if you're using the file system a lot. But with Bref, with Dynamo, with SQS, and with all the other tools that AWS and other cloud providers offer, so I mean, the queue services are available across cloud providers, you can build applications which are just very scalable and very developer-friendly. Developers are encouraged to try new things rather than thinking, oh, I can't do that because the infrastructure burden is too high, or there's too much work to do on that. So I am going to finish there. I will have a brief moment now if people do want to ask me some questions. I think we do have a little time before the session ends. We have a hand there.
What would you say the advantages are of using Lambda over using like a containerized serverless technology like Fargate?
Yeah, advantages. Oh, we have roaming microphones. I'll repeat that question, but thank you for the microphone runner person. Yeah, so advantages of using Lambda over a containerized technology like Fargate. So for anyone who's not aware of Fargate, generally with containers, you still maintain a set of instances, then you run containers on top of them, whether that's containers via Amazon's own container service or via something like Kubernetes. You still have to maintain the underlying hardware. Fargate is a solution from Amazon, which is definitely being used in their Lambda system as well, which manages the underlying machines for you. So if you want 3 containers, Fargate will work out that means you need 1 host, or 2 hosts, or 27 hosts, and it will create those hosts for you. To some extent, you lose a bit of control over the hosts that are running in your environment. One thing I would say with that is, with Fargate, you will still pay for those hosts running as if you run them yourself. So with Fargate, you don't, it's not sort of like, with Lambda, it's per second, or per second billing. Or per millisecond even. Billing, seconds and memory is the 2 things. So more memory and more time, pay more for Lambda. With Fargate, if you want a service ready to serve web requests, you're still paying something even when there's no web requests coming in. So if you were to set up a Fargate simulation, similar to what I've done today, and you all left it running, you'd all have a bigger AWS bill by the end of the month, even with no traffic, than you would have done if you were using a serverless environment. That's doubly true in AWS if you're running Kubernetes, because AWS, I think, is the only one remaining cloud provider that still charges you for the Kubernetes master node, whereas GCP and Azure don't charge you for the Kubernetes master node. So that's an interesting point with those. In terms of why you would choose something like this over Fargate, I still think that Fargate is still... You're still having to think about which containers you're using. You're generally still having to provide those containers. You could use Bref containers, but at that point, you may as well be using Bref. The only thing I think you gain by using a sort of container architecture like that is something like warm starts, so you can just leave containers running all the time to take web requests every time. But as we saw before when we called our API, I was the first person in the world ever to call my API, and we got a request back in what, like half a second? None of us noticed the time for a container to start. So having to do a cold start or a warm start is relatively low impact in this kind of environment. That said, I think if you are already running a service that's built on Fargate and is using Fargate, the benefits of switching to something like serverless, like Lambda, are probably lower than someone who's currently running on a VPS somewhere, so either VPS within Amazon, like EC2, or a VPS elsewhere. Obviously, you're going to see the most benefit from this if you're currently running on something like a big dedicated box somewhere, where you gain tons of stuff by moving. So to some extent, I think there's a pathway. The further on the pathway you are, the less you're going to see by moving it, any further. But I also feel like if you're back here, there's no point moving to there. You may as well move to there. So that's what I would say. And I am not an infrastructure expert in this sense. We haven't. We're a relatively small startup company. I play with this myself. We've run it in production. We are by no means the arbiters of what is the right way to run an application. People can come at me and say that they think I'm completely wrong if they want to. And genuinely, if your business is best sitting on a VPS somewhere because it's always sat on that VPS and it just still works and it's never had any problems, the time to implement this is probably wasted. You should probably build some new features for your customers. But that's the level of thinking about your business with your infrastructure, which is obviously also very important. Anyone else? I don't think it's coming through. You seem to be holding it in the right way, near the face.
On the note of the local testing of services, you touched upon DynamoDB and so forth when you were using some sort of executable standard. Have you looked at something like LocalStack to emulate your local environment and how it integrates there?
Yeah, so the question, for people who didn't hear, was I demonstrated the Amazon's jar file for local Dynamo. I also mentioned a queuing system that you could use. The question brought up was a system called LocalStack. LocalStack is a great way of emulating local cloud tools. They have a set of containers that are free for use, and then they have a kind of paid tier where they implement other less used services, which they've kind of built themselves. I think for a lot of things like the SQS service and Dynamo, LocalStack are basically just wrapping the tools that I was showing there anyway. So as in they're not implementing a separate set of things, because that would be difficult if they behave differently. LocalStack is well worth trying out, but at the same time, obviously when you get into something like LocalStack, it's sort of saying, oh, look, set up this full AWS environment locally, which you might not need if you're just using something like Dynamo. But yeah, totally, LocalStack, if you're setting this stuff up, and you plan to use a range of AWS services, so LocalStack can simulate S3, it can simulate Secrets Manager. I think Secrets Manager might be one of the paid ones. Various things that you might want to simulate. Kinesis, which is their streaming system, which I think is also one of the paid ones. Then, yeah, LocalStack is worth a look. Obviously, if you're just using one service, especially if it's one of the ones that's paid on LocalStack, you might be better off finding some other implementation somewhere else that isn't paid. But yeah, everyone's mileage will vary on how they do that. But yes, LocalStack, worthwhile mention, so thanks for that. Anyone else? Great, well, I think we're done. I will just briefly type up my Twitter handle again. This conference doesn't seem to be using joined in, so there's no joined in link. Yeah, I guess if you have feedback, you can deliver it direct to the face or to the Twitter handle at M1KE. Yeah, as I say, if you've got questions, you want me to show you something, I will probably try and hack and finish that queue, and maybe put a little thing out I'll put it out on my Twitter, and you can all send requests to it, and let's see what my I'll post a screenshot of my logs tomorrow. Please follow the code of conduct, but yeah, send me some code requests. Thank you very much.